In 7.1, we are going to talk about the only concept I believe that you have been taught before. In 8th grade and in 7th grade, you should have learned the Pythagorean Theorem. I even think that this is started in 6th grade. I feel like when I was teaching my daughter, going over her homework with her, that I saw Pythagorean Theorem even beginning in 6th grade. So I know you've seen this before, so I'm not going to have to highlight anything for you. Most of you know what it is and what formula to use. That's not a big issue at all. But I do want to show you this proof that I found on the internet. It's kind of a neat one. I'm going to press this button. It should take me to a website. And of course it has to load. Unless it's already loaded over here, which it is. So I'm going to let you look at it. This is a proof of the Pythagorean Theorem. This side is A, this side is B, this side is C. It starts off with that. And what it does is it has side A, side B, side C. It duplicates all four of those, are the same lengths. And then it shows you that this side is C and this side is C. C times C is C squared. Then they rearrange the triangles, and you'll see A squared and B squared is going to be the same thing as C squared. This is one way of many different ways to prove the Pythagorean Theorem. What it basically states is the square of this leg plus the square of this leg is going to be equal to the square of the hypotenuse. It only works with squares. Squaring the first side, squaring the second side, added together will equal the whole area. Very wonderful proof there. It doesn't matter which one is A or which one is B. You can mix those up. You cannot mix up which one is C. C is always the longest side. So if I don't give you a picture and I give you 3 different numbers, always choose C as the longest side. It has to be. If they're a right triangle, C always has to be the longest side in a right triangle. The only way you can use this is if you know 2 sides of the right triangle and you're trying to find the third side. We'll deal with some problems like that. Couple things that you might need to remember is that most of your answers will be in reduced radical form. That means if you have something like number 4 and you see the square root of 45, that's not in reduced radical form. You'll have to simplify that. The square root of 45 simplifies into 9 times 5, and the square root of 9 is 3. So I'm hoping you know that this side is 3 root 5. Right? Like, that's simplified radical form. If you have forgotten simplified radical form or reduced radical form, you might want to check out the 0.2 notes. Those notes will remind you how to deal with radicals in case you need them. The last thing I need, second to last thing, is this thing called a Pythagorean triple. What is a Pythagorean triple? It's when it comes out nice and even. Not everything comes out nice and even. If it does come out nice and even, it's called a Pythagorean triple. There are certain Pythagorean triples that are used more than others. The most famous one that is out there is one that carpenters use, or people who are in construction use it all the time. It's called the 3, 4, 5 triangle. 3 squared plus 4 squared will always equal 5 squared. It is the only one that's like that. Don't think that 4 squared plus 5 squared equals 6 squared. It doesn't work like that. These 3 together work all the time. The way construction workers use this is they will measure the side. You can't see that very well. Let me turn this on. I love breaking out the measuring tape, to be honest with you. They will measure the side of some object with their tape measure. They'll make a mark on one board. They go to the other side. They'll measure 4 feet out, make another mark, and then they'll measure between the 2 marks and make sure that it's 5 feet. If so, they know that they have a right angle. It's a way to do it without a square. They know that the math says it has to be at a perfect right angle. 3, 4, 5 is a Pythagorean triple. Some other famous ones, if you double 3, 4, 5, 6, 8, 10 also works. You can triple it, you can quadruple it. It's the 3, 4, 5 multiplied by a number. It works. Other Pythagorean triples that we use are like 5, 12, 13. There's a few other ones as well that will work out. If it doesn't, it's not a Pythagorean triple. The last thing that we need to talk about of how we can use the Pythagorean theorem is, could we also tell if it's a right triangle or if it's obtuse or if it's acute? Sure, the Pythagorean theorem can tell us that as well. What that is if I know that a squared plus b squared equals c squared, then I know it has to be a right triangle. But if the c squared is too big, if the mouth eats the c squared and the a squared plus b squared is smaller than that, think about what that picture would look like. If the c squared is bigger than the a squared plus b squared, then guess what? That would mean that it has to be an obtuse triangle. Whereas, if the c squared is smaller than the a squared plus b squared, if the a squared plus b squared was greater than the c squared, then you would know that this c squared is smaller than that squared and that squared, that it has to be acute. You could figure out without a picture whether something is acute, right, or obtuse using the Pythagorean theorem as well. That's something that you probably haven't done, at least I don't think that you did, in Advanced Math 8 or in 8th grade or in 7th grade. Have you done that in 7th or 8th grade? Does anybody remember doing this one there? So this is new for you, okay? So now what we have some examples. 4, 10, 16. You guys should have a packet hopefully in front of you. If you want to do this in your notes, you are welcome to do it in the notes page, or if you want to, I think some of you are going to want to write it down in your notes page and then possibly do it on your own in the worksheet. Or if you want to save yourself some time, you can go right over into the worksheet. It's up to you. I'll let you decide what works best for you. Number 4. Identify the values of A, B, and C. Write a question mark for unknown values. Okay. Then find the missing side lengths. They want you to use a question mark. Kind of interesting. Normally we put an X there or a Y. Then find the missing side lengths. Leave your answers in simplest radical form. So if I was doing number 4 and I needed to find this side, the most important side to know which one is which is the C. The root 45 is C. It doesn't matter which one is A or B. You can have the 3 as the A, or you can have the question mark as the A. It doesn't matter. So I'm just going to do Pythagorean theorem. A squared plus B squared equals C squared because it's a right triangle. I know 2 sides. I'm going to plug in the 3 as the A. I'm going to plug in the question mark as the B. And then the C, I'm going to plug in root 45 for the C, and then I'm going to square it. Now I'm going to do this in 2 different ways because there's the short way, then there's the longer way, and they need to be the same, but some of you are going to want to do the longer way. So let's do this. 9 plus question mark squared equals. If I were to think about the square root of 45 squared, that is the same thing as root 45 times root 45. Back in 0.2, I said if you have a pair on the inside, that can pop out. This makes 45. That's my way. I can't tell you how many people simplified this, which is fine. This is a second way to do it. To 3 root 5. If you do the 3 root 5, you still square it, it would make 3 root 5 times another 3 root 5, which is 9 times root 25, or root 5 times 5, which makes the pair and pops it out, and it's still 45. Once you get to here, you subtract the 9 from both sides. And then to get the question mark by itself, to get rid of a square, we do the opposite of square, which is square rooting. Technically, this should equal a positive and a negative value. Whenever we do a variable or unknown value squared and we're square rooting it. But because we're talking about a geometrical distance, distance always needs to be positive. We are going to ignore the negative possibility, and we're going to say that it needs to be 6 units long, whatever that may be. Any questions on number 4? Number 10. For each pair of numbers, find a third whole number such that the 3 numbers form a Pythagorean triple. Now, C is always the longest side. What we don't know in this question is we don't know if this is A or B, or if this is B or C. We have 2 sides. I just don't know if this is the longest or if there's a longer piece. This could be, let's just put it like this. This could be B or it could be C. The longest side, this can't obviously be A because there's something shorter than it, right? Like it's not A because 60 is way bigger than 32. It's either the middle one or it's the longest one. That's what we don't know. But for each pair of numbers, find a third whole number such that the 3 numbers form a Pythagorean triple. They're expecting you to know what that means. They want to know what would the other number be that would make it come out nice and even without any decimals. So you might have to figure out, well, is there a C value or is there a B value? Like you might have to figure it out in one of the other 2 ways. So here's what I would do. I would figure out what this is, and I would figure out what this is. Because these numbers are somewhat big, I'm going to use a calculator because I don't really want to spend a lot of time spending 32 times 32, which comes out to 1,024. I could do 60 times 60 in my head, which is 3600. And in my mind right now, there's 2 possibilities. Either it's this squared plus something squared equals that squared, or it's the other way around. But I'm just going to guess one of them. I'm going to pretend that it's A and B and maybe there's a C equals a C value. Like that's what I'm kind of thinking right now. A squared plus B squared, and then I'm thinking about it equaling C squared. I'll know if it works when I square root if it comes out to a nice and whole number. Let's check. This makes 4, 6, 2, 4. And we're going to see, is that square rootable? Is it a nice whole number? Square root of 4, 6, 2, 4. Does it come out nice and neat? What'd you get? 68. Ooh, awesome. Somebody said 68. That's what I got too. That makes me feel better. If it comes out to a nice whole number, then that means we found a Pythagorean triple. If we put this over here and subtracted the 1024 and then square rooted it, let's just check what that would look like. 3600 minus 1024. And we were to square root that answer. It comes out to about 50.75. It's 4 root 161. That's not a Pythagorean triple because it's irrational. Pythagorean triples come out to nice whole rational numbers. Okay? Keep in mind, not always will it always be equal to the c squared. It might or it might not. You might have to play with that in those problems. Last example. Just wanted to double check. Yep.
What if it's equal to gold?
I don't think it can. I can't, well, let me just say it this way. I can't think of a possibility where that would work. But I don't know if I've explored that entirely yet. But I'm going to say I don't think that it can. Unless you can tell me otherwise. Let's go with that. Number 16. The lengths of the sides of the triangle are given. Classify it as acute, right, or obtuse. The number one thing about these is that, okay, this is how they gave it to us, but on a quiz or a test, they may give it to you in any order. This might be the B. This might be the C. You have to know what it is. So if they give you something like 7 root 3, you probably want to know what that is as a decimal. That's where I go and take my calculator, type in 7 root 3. My calculator tells me it's 7 root 3. Well, there's a way to switch it to a decimal. SD stands for standard decimal on these calculators. And what it can do is it can take the 7 and take the root 3 and multiply those two values. If you don't know what root 3 is about 1.73. And it's going to multiply that by 7 to get the value. It's about 12.12. This is about 12.12. So what that means is that this is your A, this is your B, and this is your C. On a quiz or a test, though, I might change the order because I want to see, do you know which one the C value is? Do you know where to put the C value in correctly? If it says classify each triangle as acute, right, or obtuse, we're taking these three side lengths and we're trying to figure out, is A squared plus B squared, how does that compare to the C squared? I'm going to put a little box right there. I'm going to put 7 squared, 7 root 3 squared, and 14 squared. Keep my box right there. The number one mistake that students make. I'll talk about the number one mistake and the number two mistake. The number two mistake is not putting the C in the right spot. A lot of people don't make that mistake very often. But the number one mistake the students make is this 7 root 3 squared. Okay? How do we do 7 root 3 times 7 root 3? I'm going to suggest to you, always write it out so you don't make that simple mistake that students make. If you do this by hand, you are way less likely to make the simple mistake. 7 times 7 is 49. Root 3 times root 3 makes that pair, and the 3 pops out to multiply that 49. It makes 147. Now, why is that important, or where do students make the mistake? If they make the mistake because some students don't realize that the parentheses make a difference. Let me show you what I'm talking about, because a lot of you will end up tutoring somebody someday about this. If you just type in 7 root 3 and you type in, delete, squared. If you type it just like this, your calculator is going to treat it differently as parentheses 7 root 3 squared. It's only going to square the root 3. Root 3 times root 3 is root 9, 3. 3 times 7 is 21. Watch. Versus 7 root 3 parentheses squared. Look at the difference between these two answers. This answer before, no parentheses. This answer with parentheses. Do you see how the calculator gives you different answers? And it's because some of you ignore parentheses when you're doing your work, and when you go to a calculator to help you or to do some of the problems to speed things up, you forget that the parentheses are necessary when you're inputting things into the calculator. Number one mistake right there. That's the most common mistake that I see. If you tutor somebody or you're working with somebody, don't forget parentheses. Okay? 147 plus 49 plus 49 is 196. And this side's 196. What does that tell you? It's a right triangle because they're equal. If it was less than, you would say obtuse. If it's greater than, you would say acute. And that's stuff I'm expecting you to know. We'll stop your notes right there.